Presently, the most relevant technology for hydrogen production at industrial scale is steam methane reforming. In a multi-stage process, methane and water vapor are converted into hydrogen and CO2. As can be seen from the reaction equation, 1 mole of CO2 is formed for each mole of methane, CH4.
However, 1 mole of CO2 is formed additionally. In other words, for each kilogram of hydrogen, almost 5.5 kilograms of CO2 are produced solely from the raw material.
Taking into account the overall CO2 emissions of the hydrogen production by steam methane reforming results in around 12 kilograms of CO2 for each kilogram of hydrogen.
Coming back to our example with the car. Using hydrogen produced by steam methane reforming, a smaller amount of CO2 is produced for a distance of 100 kilometers when compared to conventional fossil fuels.
Depending on the specific fuel consumption in the range of 14 to 20 kilograms of CO2.
However, this is just a small improvement. There is an alternative technology for the production of hydrogen, water electrolysis. Here, water is split into its components, hydrogen and oxygen, in an electrolyzer using electric energy.
As can be seen from the reaction equation, there is no emission of CO2.
However, this process requires a relatively high amount of energy. Even with a high efficiency of around 80%, that means an energy requirement of roughly 180,000 kilojoules for each kilogram of hydrogen produced.
Using the presently available electric energy mix in the European Union, that would add up to higher CO2 emissions compared to steam methane reforming.
Hence, the electric energy for the electrolysis has to be generated from renewable energy sources, like hydropower, wind power, solar power, or geothermal energy.
Unfortunately, the high energy requirements for the further increasing demand of hydrogen will not be available from renewable sources in the near future, at least not to great extent.
Therefore, we need a bridging technology that can deliver hydrogen at a low energy demand and a low carbon footprint.
Okay, is such a technology available?
Hydrogen and carbon are two essential resources for future climate-neutral technologies. Their demand will rise strongly within the next decades.
The project Sustainable Hydrogen and Carbon Supply and Energy Mining investigates and further develops methane pyrolysis for the production of hydrogen and carbon. It is financed by RAK Austria,
First Alpine,
Primatools Technologies Austria,
Wien Energie
and Montanuniversität Leoben.